Okay, y'all. So we are going to do the second half of the review. We got through problem 8 last time. We're going to start at problem 9 this time. I think there's like a question that I don't particularly solve. And the main reason is because this is to review for exam 1, and I know it's not on there. And it's, you know, kind of time consuming, and I don't want to waste time on that. Okay. I don't know if I want to use green. Where we left off, we were actually fixing to look at transformations of a graph. And then, like on your homework, it gave you multiple different options, and you're able to pick which one did equal like that transformation to that function. For the exam, there'll be a graph and there'll be like a function already drawn, and it'll tell you to like apply these transformations. So you just need to know that like if you have a numerical value inside of the parentheses, you actually do the opposite of what the sign says. So for example, on 9, y'all should have a review with you. For example, on 9, it's going to probably be nearly impossible to see here, y'all. But this was B. This is the one I'd looked at. And if you look at the transformation that's applied in parentheses, it says a -3. In parentheses means left to right. And you do the opposite of the sign from what you might think. That negative, I think left, but it actually means right. So I know that this -3 right here means that I'm going to go to the right 3. And then on the outside of the parentheses, I've got that, y'all just can't see it, so y'all have y'all's, okay? On the outside of the parentheses, I am subtracting 3. I have another like -3 and -3. And that actually, you do what it says, and because it is a minus sign, you would go down. So that would be a vertical shift down. So I'm going to go down 3. So I just found right there at the origin, this point, I scooted over 1, 2, 3. I went down 1, 2, 3. And then you just kind of give a rough sketch of it. It does not have to be perfect. You don't have to plot 5 different points and draw the exact same function that I give you. Okay, you can just plot where, you know, the origin was here, it went to here, have your dot right here, and then just kind of freehand whatever the function looks like. Okay, so that's how you do the transformation of graphs. You'll be given a graph and then just literally transform it based on what it tells you to do. Okay, so let's do problem 10. Okay. And honestly, I pretty much just do all the B's still. And I need to see problem 10 to know what we're doing here. Problem 10 says to find the domain of a function. So for my B, what I have is f of x equals x squared negative 6x plus 11. Does anybody remember what I kept saying over and over and over again about polynomials and their domain? What is it? Yep, all real numbers. You can, on your exam, literally write the symbol. So for my domain, you can tell me it's all real numbers, or you can throw it into interval notation. You just have to know that with domain, you always use interval notation. There's something else called like, I can't even think of what it's called right now. There's multiple different ways to show me this, but for domain, always use interval notation. For range, always use interval notation. Increasing, decreasing, just get used to interval notation, okay? So that's it for that trinomial. Now, let's just say that trinomial was in a denominator. Remember we did that last class? That's when you actually need to see when it equals 0. So your domain won't look like this. It'll look different because there are going to be some spots that it can't actually equal, right? I did see also, y'all, which was f of x equals the square root of x minus 1, and it asked me to find the domain. So what I know about square root functions is that I can't take the square root of a negative number. So I know I can go as small as 0. I just can't go less than 0. So I wonder what makes this 0. And if you look at it, if I do a positive 1 right here, I do 1 minus 1, I get 0, right? So that tells me that my domain can actually equal 1 and then go all the way up. Oh, I think in C it's a plus 1. Thank you. I didn't see it until I looked down again. In C, it's actually the square root of x plus 1. The only thing that changes here is what makes that 0. Instead of a positive 1, it would be a negative 1, right? and then parenthesis around your infinity always. Okay, so let's do problem 11. And of course, B. Problem 11 says to find f plus g, f minus g, f times g, and f divided by g. That's the algebra of functions. So quite literally, you're going to use the functions that they give us, and then there's just a bunch of algebra. Not even really a bunch, but I mean, there's enough to where you need to make sure that you can solve them. For my b, I have f of x equals 3x plus 8. And then for my g of x function, I have x minus 7. So for f plus g, I've got f plus g, and that's of x. So what I do is I take my f of x and I add to it my g of x. And if I do that, I have 3x plus 8. Here I just have plus x minus 7. Y'all, we combine like terms. In order to combine like terms, when you're dealing with variables, they have to have the exact same variable and the exact same exponent. Because the rule is that we keep and keep. You keep the variable, you keep the exponent. So they have to be the same, right? If they're not the same, how do you know which one to keep? Here I've got a positive 3x and a positive x. Looking at the coefficients, signs are the same, so you add and keep. And then for your variables, you keep and keep. And then those are actually like terms also. They're just plain numbers that don't have a variable attached to it. You just combine them. You just look at the signs. Here, you've got multiple different ways you can do it. Enter 8 minus 7 in your calculator, get 1. You can just look and see that 8 minus 7 is 1, or signs are different. You subtract, keep the sign of the larger. Pretty much everything y'all hear out of my mouth is the way I teach my elementary algebra and my intermediate algebra. So if there's something you don't understand, make sure you ask me, okay? Because I'm breaking it down as much as I can, okay? So this is going to be, it's going to look kind of ugly here, but f plus g of x. Okay, so that was me adding the two functions. It also told me to subtract the two functions. There's a very important thing that you have to do whenever you subtract the functions. I'm not just subtracting something in my g of x from f of x. I'm subtracting the whole g of x from f of x. So as far as notation is concerned, let me go ahead and write f minus g of x. What you do is you take your f of x and you subtract from it your g of x, right? Now, what is it? My f of x, I have my 3x plus 8, right? And then when you look at the operation, it's a negative sign. It's minus. And then you use parentheses here, y'all. If you don't use parentheses here, you're essentially only making one term in your g function negative. But when you do use parentheses, we're actually subtracting the whole thing. It's very important that you do that. And my g of x is x minus 7. So first and foremost, distribute that negative sign, which technically just makes your signs of the binomial inside of the parentheses change. It was positive, now it's negative. It was negative, now it's positive. Now, combine like terms. So my f minus g of x equals, I've got positive 3x minus 1x. Signs are different, so I subtract. I keep the sign of the larger. Because I'm combining variables, I keep and keep. That's just 3x minus 1x is 2x, okay? And then here, positive 8, positive 7. Signs are the same, so I add and keep, 15. And that would be the answer for me subtracting the two functions. Okay, now we multiply the two functions together. And I don't want to say of course, but Of course, because we're doing multiplication, both functions need to be in parentheses because those parentheses is what tells us to multiply. That's what implies multiplication. So I put my, I was just going to go ahead and do it. What's happening, y'all, is this, f of x times g of x, okay? So I'm going to put my f of x in parentheses. I'm going to put my g of x in parentheses. Because there are two binomials, bi meaning two, binomial meaning this has two terms, this has two terms, right? I'm going to scoot up, y'all. What I do is FOIL, first, outer, inner, last, okay? I take my two first terms of the binomials. That's this right here. That's the first term in this factor. This is the first term in this factor. When you do that multiplication, you get the 3 times the 1, right? 3 times 1 is 3. Signs are the same. Those are both positive, so this is positive. Now, when you do your variables, there's exponent rules that state when you multiply variables, if they're the same variable, you keep the variable and you add the exponents. So x times x is x squared, right? Now, using FOIL, the second letter is O, which is outer. You take these two terms that are on the outside. There's 4 numbers there, right? These are the ones on the outside. So I'm going to multiply these two together. If you do 3 times 7, you get 21. Signs are different, so it's negative. Don't forget your variable. My multiplication that I just did was 3x and the 7, right? So because that x was involved in the original multiplication, it's going to be a part of my product. It doesn't just fall off, oh, this doesn't have an x, it goes away. No, you keep that x. Don't forget it. Now, third letter in FOIL is I, which means inner. Of these 4 terms, those are the inside ones, right? So now I multiplied these two. When you do 8 times x, you just get 8x. They're both positive, which means my product is positive. Lastly, in FOIL, you do the last terms. First, outer, inner, last. So looking at this pair, that's last. Looking at this pair, that's last. Let's multiply them together. 8 times 7 is 56. Signs are different, so it's a negative 56. And now I've gotten to the point to where I can combine like terms. Okay, so my 3x squared, there is not another term that has that same variable, same exponent. So nothing can be like combined with it. So I'm done with that. If you look at your middle terms, those both have an x to the first power. They're alike. They can be combined. Like you can do math on them. So what I do is I look at the numbers. 21 and 8, those signs are different. So I subtract, keep the sign of the larger, keep my variable, keep my exponent. Used those. What I have left is a negative 56. So that is the product whenever I multiply those two functions together. Oop, almost crossed out my answer. That is the correct answer. Okay, so I just went ahead and did the algebra functions for the addition, subtraction, and multiplication. It asks you what the, what's it call it? It asks you what the domains are. And your domain for these functions, if you look at my f plus g, I got a polynomial. If you look at my f minus g, I got a polynomial. If you look at my f times g, I got a polynomial. The domain for all 3 of those are just all real numbers, negative infinity, positive infinity, okay? Kind of did that as a second thought because I just know they're all the same. They're polynomials. Now, when I do the quotient rule, basically when I divide them, it won't be. I'm actually gonna have to figure out what that domain is based off of what my denominator is. So if you take f of x and you divide it by g of x. So if we do f of g of x, what we're doing is doing f of x over g of x. My f of x was 3x plus 8, is that right? And then my g of x was x minus 7. Mathematically, y'all, there is no way to factor this any further. There's not a trinomial on the bottom. It's not, you know, I don't see common terms to cancel. It's just my g is under my f, and I can't do anything else. So the only thing I'm concerned with now is what is my domain? What causes that to be 0? Because that's somewhere I know that like it would be undefined and we can't have that. So it can't be that. And if you notice, if I add 7, right, the positive number 7, I'll get 7 minus 7, which is 0. That's the only number that I could put in the denominator that causes this function to be undefined. So 7 is what it cannot equal. My x cannot equal 7. So for my domain, it can be all numbers except for 7. Does that make sense, y'all? So far, so good? Yeah? Okay. It gets hot up here. Okay. I'm actually going to switch to a new piece of paper to start 12, just because I know it's probably going to take a whole piece of paper. So for 12, I chose to do B because apparently I love B. And also, if you look at your review, there's a number missing. It was a typo on my fault. On like, it was on me. My G of X, y'all, should say X plus 7. Okay, I literally just didn't even see that until I was circling things. So for 12, we're gonna do B. I already know that it's gonna want me to find all these different things. I'm first just gonna write down my function, and then I'm gonna find each individual thing. So my f of x is 5x. I think I'm gonna do it like this. We're gonna see how this goes. My other function that I'm given. And the reason why I'm doing different colors, this is composite. It has the little bitty O. It looks like fog. I'm plugging stuff into other stuff, right? So my G of X, you can kind of barely tell. My G of X is X plus 7. That's what I said it was. That's better, maybe. Gotta use red. It's gonna be super ugly now, but I'm actually gonna make my G of X red, okay? Okay, so the first thing it tells me to find is it's the composition function of f of G of X. And the way it looks is in parentheses, F, the little composition symbol, G, close parentheses, open, X close. That is saying f of G of X. What I told y'all to do is when you say the word of, open a parenthesis. So this is better written and easier to understand to solve if you do f of G of X. Now, that's what I'm supposed to use my red, y'all. Now, you should notice that I've got my G of X being plugged into my f of X, right? This is where I'm supposed to use red. It's really hard to switch. So let me actually plug that in. If I do f of, what's my G of X? X plus 7? This is literally the exact same notation right here, f of X plus 7. If you notice, the only difference is I'm adding a 7 here. So, but instead of seeing a normal plain X in my function, it's going to change to this binomial, these two terms. So what I get is, I actually want to have this, I want to write it like that, y'all. So my f of X plus 7 is, look at your f of X, I have 5 times, this is where X plus 7 goes. Because in the function it was an X, but now it's changing to an X plus 7. What you do here is distribution. 5 times X is 5X, 5 times 7 is 35, both positive, so it's positive. That's the answer to f of G of X. That's plugging in G of X into my f of X, okay? Okay, so it then tells you to find G of f of X, but what I wanna do first, since I already found f of G of X, I wanna look right here where it tells me to find f of G of 3. This is f of G of 3. There's two different ways you can go about this. You can look at your g of x, make your x your 3, right? So I would get 3 plus 7 is 10, and I'm doing f of 10. Perfectly fine, right? You'll get 50. 5 times 10, I don't know if y'all can see it, there it is. 5 times 10 is 50. Or if you wanted to, this is what I just solved when I plugged them into each other, right? You can actually just take this 3 and plug it right here, and you get 5 times 3 plus 15. So either way you do it, it's fine. I'm actually going to do it like this. I'm going to use what I just solved, plug in the specific value they want me to find. So I get 15 plus 35, which is what, 50? So you see how if I actually did f of 3 plus 7, well, that's f of 10. F of 10, plug in 10 here. I mean, it's either way you go about it, you're still going to get the same answer. It just depends on which way makes more sense. This way I hadn't showed you. The way I'm telling you you can do it is what we did do in class. That's two different ways to solve those. Okay, so now let's do the g of f of x. Let's do the g of f of x. I just want to make sure I cover everything, y'all. G of f of x is g of f of x, which is g of, plug in my f of x. My f of x is 5x. So now look at my g of x. My g of x is x plus 7, but now it's 5x plus 7. Okay, so after you find that, they want you to find g of f of x. I'm sorry, of 3. I don't know why I said that. I was trying to read at the same time. Now they want me to find my g of f of 3, which is g of f of 3, which I can just plug my 3 into what I just solved, and I would get 5 times 3 plus 7. 5 times 3 is 15 plus 7 would be 22. Okay, let's do problem 13. Problem 13 says to find the inverse for these one-to-one functions. I'm going to do a specific one. There's also a video on the YouTube page of it as well. This is the one that I actually messed up this morning. Okay, so problem 13. I did C. Yeah, because if I just noticed that B is a really great, awesome one to find the inverse of, but I wanted to kind of match the level of difficulty that's on the exam. Okay, so for C, it says f of x equals x plus 5 over x minus 8. My rules for finding the inverse are to switch my x and y variables and then to solve for y. This particular function, it's written with f of x. It's not written with y, but those are interchangeable. They are the same thing. So I'm going to write it with the variable y. I'm literally just rewriting the exact same. The only thing I did was I changed the f of x to y. So I just rewrote it. Now I actually follow the two steps, which is switch and solve. So switching gives me x equals y plus 5 over y minus 8. Okay, so now I'm solving for y. I've got a y in a numerator and I've got a y in a denominator. So, I mean, in all honesty, like that doesn't help me at all, right? Like I'm gonna need whatever's in the denominator to come out of the denominator. What I'm doing here is the inverse. What I mean by that is like the opposite of the opposite of division would be multiplication. So if I'm going to multiply this by the denominator so that I can get it out of the denominator, so that I can cancel the denominator, right? Whatever you do to one side, you have to do to the other side. So I'm also going to multiply this by y minus 8. Okay, so on the left-hand side, I have x times what's in the parentheses. So I'm just going to write x in parentheses, y minus 8, close parentheses, equal. Do you notice how those cancel? Which is like the reason why I multiplied by the denominator, so it would cancel, because that's what happens. So what I have on the left-hand side is just y plus 5. So very important here, I have my x right next to a parenthesis, which implies multiplication. So I need to go ahead and distribute that x into the parentheses. So x times y is just x, y. X times a negative 8 would be a negative 8x. Right-hand side, I have y plus 5. This is where I messed up in the first class. And like literally, it would make sense if someone else also made this mistake. I know I'm trying to solve for y, right? And so what I wanted to do right here is like pull out their common factor, get y. And I went down a rabbit hole for a second, okay? What I need to do to actually solve for one y is get all of my y's together, right? Just like when you're trying to solve any equation, you want to isolate the variable that you're solving for. Isolate means getting it alone, right? So the only way, if I have a y on the left and I have a y on the right, that I'm going to get them alone is to like put them together. So I want to put my y's on one side and I want to put my x's on the other. That's a very important step to solve this correctly, okay? Now, what I mean by that is, okay, I'm going to kind of do two steps in one here, y'all. I need this negative 8x to move because it has an x. And I need this y to move because I need my y's together. So if I do that, I get, okay, so let me go and do this to really show you. If I'm subtracting it from one side, I'm also subtracting it from the other, right? And if I'm adding 8x here, I'm also adding 8x here. Now what I get here, those cannot be combined. They're not like terms. I just have xy minus y. Those cancel. Equals, those cancel. Those are not like terms. You cannot combine them together. That does not become a 13. You just can't, okay? That is literally just 8x plus 5. Now, do you notice how on the left-hand side, I have my two y variables, like I'm almost there. I need to solve for one. What you need to notice is that because both of those terms have a y in common, it's their greatest common factor. So you literally, just like when we do the AC method, I can pull that y out. So if I actually pull the y out, what I'm doing is division. X, y divided by y, those y's would cancel, right? And I'm just left with x. Now y divided by y is 1. Signs are different, so it's negative. And then on the right-hand side, I have equal 8x plus 5. Y'all, I'm going to have to come up right here. Okay, so literally last step. I'm trying to solve for one variable, y. It's being multiplied. Yes, it's being multiplied by something. I need to do the inverse. The opposite of multiplication is division. So I need to divide both sides by this, that whole right here, what's in the parentheses. And if I do that, it'll cancel on the left-hand side, and we'll have 8x plus 5 divided by x plus 1 on the right-hand side. That's the inverse. Okay. Y'all, I didn't do problem 14 because there's no need to do problem 14. Okay. I did do problem 15. Where's my paper? For problem 15, I noticed that there is a baseball player making a ton of money, and he was offered to make even more money every single year. And it wants me to specifically find a year of like during his employment, like how much he's going to make during that year, right? Well, I know that yearly he's going to get his normal salary, and then it's going to actually be, it's going to increase every single year, right? So what you need to know for these problems is just his starting salary, which is going to be your A sub 1. And if you read it, it says he's going to sign a contract beginning salary, that's starting, at $8 million. Okay, so then it tells me for the first year, and an annual increase of 9% per year beginning in the second year. That 9 with the actual percentage symbol doesn't necessarily mean much